Good day, everyone. Welcome back to Medicinal YouTube channel. So today we are going to be talking about the topic stoichiometry. Now, before we go into that, please, if you have not subscribed to this YouTube channel, please ensure to subscribe. God bless you. It means a lot to me. Now, today's topic we'll be talking about stoichiometry and how it affects our daily calculations in chemistry. Now, majorly, stoichiometry is in two types, which is stoichiometry of reaction and stoichiometry of composition. Having said that, having established that, we'll be moving forward to discussing what we mean by mole concept. Now, we can't talk about stoichiometry without talking about the concept of mole. Mole is very important in stoichiometry, and it is a convenient unit of measurement that is applied to specified units. Now, this specified unit in turn represent a specific number of items. What do I mean? For example, we have a mole here, and a mole in turn will be representing a specific unit of measurement. For example, we have Avogadro's constant, which is represented by Na here, and in turn, this Avogadro's constant will represent a specific number of items or a specific number of particles, which is 6.02 times 10 raised to the power of 23. Other examples we can use is, for example, we have molar volume. Molar volume of a gas at STP will be 22.4 dm cube at STP. Now, for better assimilation, you can say a mole represents a dozen. And we all know what a dozen means. A dozen represents an item which comes in 12 bundles or in 12 items. So you can say a mole can represent any number of quantities, and it's just the basic units of chemical calculation. Alright guys, before we move on, there are some formulas we need to establish so that at the end of this video, we'll be able to solve any question we come across in stoichiometry as long as chemistry is concerned. Number one would be on substance of known masses. Now, when we have substances of known masses, there is a particular formula we use to solve them. Substance of known masses, it will be mole equals to the mass known, which is in grams, over molar mass, which is in gram per mole. Most times your molar mass is given to you in the question. Now, number two, we are going to be establishing a molecular formula for solutions. For solutions, to be mole equals to concentration in mole per dm cube times volume in dm cube. Most times your volume will be given to you in cm cube, so what you have to do is to divide by 1000 to get your volume in cm cube. Now, number three will be for gases at STP. So gases at STP. Now, STP means standard temperature and pressure, which for temperature it is 273 Kelvin, and for pressure it is 1 atmospheric pressure, 1 atm. Now, for gases at STP, you can find mole with N equals to PV over RT, where P is the pressure at STP, which is atm, and T is temperature, always in Kelvin, always in K, and V is volume, should be in dm cube or liters. Dm cube or liters, the equivalent units. Or okay, R represents a constant, molar constant of a gas, which is 0.0821. Now this 0.0821 must be carrying the units atm, dm cube, per mole, or Kelvin. Now it should be carrying all these units accordingly, because that's the basic standard unit for molecules of a gas. Now number 4 would be for elementary particles, which is mole is equals to number of particles over 6.02 times 10 raised to the power 23. Earlier we established this constant as one of the constants representing mole, and this is Avogadro's unit, Avogadro's constant. Alright guys, right over the blackboard we have some examples we can use as a basic start to understanding the concept of mole. Test 1 is saying that we should calculate the number of moles that is present in each of the following. Now we are going to be solving this pertaining to our formulas that we have established on ground. Now number 1 is saying 5.3 grams of NaCO3. Now the first thing to do is to write down our chemical formula for solving this, which will keep us in track to what we are doing here. Now remember the first formula I gave, which is mole is equals to mass in gram over molar mass in gram per mole, molar mass in gram per mole. Now we already have our mass, and our mass is equals to 5.3 grams, and our molar mass we don't have. Now our molar mass will be 2 atoms of sodium plus carbon plus 3 atoms of oxygen, and this will be 2 times 23 plus 12 plus 3 times 16, and all these all summed up together will give us 106 gram per mole. 106 gram per mole. That's our molar mass. Now having established our molar mass, we'll go forward to looking for our mole. Our molar mass over here, we just write it over here. Molar mass is equals to 106 gram per mole. Now our mole here becomes simple division, which is 5.3 divided by 106, which will give us 0.05 mole. Now just punch that in your calculator and it's very easy to get. Now next up we are going to be solving example 2, and example 2 is find the mole of 4.25 times 10 raised to the power 21 atoms of copper. Now to solve this, we are going to be using our last formula we established, is mole is equals to number of particles over 6.02 times 10 raised to the power of 23. You can take a pause to this video and try if you can solve that on your own. Okay, if you have tried, let's do it together. This will be 4.25 times 10 raised to the power of 21 over 6.02 times 10 raised to the power of 23. and this will give us 7.06 times 10 raised to the power of 3, raised to the power minus 3 rather, mole. Now this the number of particles, or rather the number of mole we have in 4.25 times 10 raised to the power 21 atoms of copper. Now for Roman figure 3, we were given volume as 200 cm cube and concentration as 0.025 mole per dm cube. Now, having established that, we'll be using our second formula we gave, which is mole is equals to concentration in mole per dm cube, which we have here, times our volume in dm cube. Now you notice that in our question our volume is in cm cube. Now all we have to do to convert to dm cube is to divide by 1000. Now divided by 1000 we'll be having 0.2 dm cube. Now here we'll come over here and write mole is equals to 0.025 times 0.2 volume in dm cube after dividing by 1000, and this will give us 0.005 mole. As easy as that. Now we're going to go to Roman figure 4, and Roman figure 4 is of hydrogen at STP, so we should find the mole of 16 dm cube of hydrogen at STP. Now this will be mole equals to volume over 22.4 dm cube. Now we can only use this formula for gases at STP, and STP means standard temperature and pressure. Now our mole here must always be in dm cube. Remember, if you were given your mole here in cm cube, you convert just as we did in our previous question. Now the mole here is in dm cube, so there's no need to convert anymore. So here we'll be having 16 dm cube over 22.4, and at the end we'll arrive at an answer which is 0.71 mole. Now for example 5 is use the mole of an ideal gas. Now mole of an ideal gas equals to N equals to PV over RT. Now where P must be in ATM, and our P in the question is in millimeter mercury. Now to convert to ATM, it will be 720 divided by 760, which is our standard pressure. Now our volume must be in dm cube. Our volume must be in dm cube, and to convert to dm cube, as we have earlier said, we will divide by 1000. Our temperature too would be in Kelvin, but in the question it is in degrees Celsius, so 37 plus 273 will be converting our temperature to Kelvin. Now this will be equal to 0.947 atm. This will be equal to 0.25. This will be equal to 310 Kelvin. This will be equal to 310 Kelvin. While our arrow is a constant, which is 0.0821. So, having established our number and quantity of pressure, volume and temperature, we'll move forward to solving the question, which is number 5. So we have N equals to PV over RT. where our P is equal to 0.947 times V, which is 0.25, divided by our temperatures, which is 310, while R is a constant, which I told you earlier that it is 0.0821, and after multiplying these together and dividing, we'll be having 0.0093 mole. So this will be our final answer. So here we have number 2, which is test 2, and we're asked to calculate the volume of nitrogen that will be produced at STP when the decomposition of 9.6 gram of ammonium diisonitrate 3 is effected. So what we have to do is to write the balanced equation for this decomposition reaction. The balanced reaction, or the balanced equation for the reaction, will be NH4 NO2 will decompose to give us nitrogen gas, which is N2 plus H2O. Now this reaction is an homogeneous reaction because all the reactant and the products are gases. So this H2 here is steam, which is a gas. And then when you see a question like this, the first thing to do is to write out your balanced equation. It must be balanced. Most examiners will give you the balanced equation for the reaction. Most would not, so you need to learn how to balance the equation. So nevertheless, for this equation to be balanced, we need to add 2 molecules of steam. So here we have 2, and that would be 2 molecules of steam. So we are having 4 hydrogen at the product side, and we are having 4 hydrogen at the reactant side. So we are having 2 oxygen here and 2 oxygen in that side. So you can just examine the equation and see for yourself that the equation is well balanced. So what we have to do next is to bring down, remember, we are looking for the volume of nitrogen that will be produced at STP from the decomposition of 9.6 grams of ammonium diisonitrate 3. So what we are dealing with, what we'll be using to solve this question is ammonium diisonitrate 3, which is this, and nitrogen gas. So we are not using the molecule of water here to solve this question. So since it is same mole, the question will be more easier to solve. So this is 1 mole of ammonium diisonitrate 3, and this is 1 mole of nitrogen gas. Now the next thing to do is to work with the quantity that was given to you in the question so that you can use it to get the other required quantity. What do I mean? In this question, we were given 9.6 gram of ammonium diisonitrate, and we need to find the mole of ammonium diisonitrate in this reaction so we can compare it to the mole of nitrogen. What do I mean? Remember I said mole is equals to mass over molar mass. So the mass that was given to us in this question is 9.6, but yet we don't know the molar mass of ammonium diisonitrate 3. So what are we going to do? We are going to look for it, and this is ammonium diisonitrate 3. So here we have 2 atoms of nitrogen plus 4 atoms of hydrogen plus 2 atoms of oxygen. So 2 times 14, which was given us in the question over here, it will be 28. Now 28 plus 4, which is 4 times 1, give us 4, plus 2 times 16, which will give us 32. So all summed up together, we'll be getting 64 grams per mole. 64 grams per mole. Hope you understand how we got our molar mass. Just going to recap over it. So here we have 2 moles, two atoms of nitrogen added to 4 atoms of hydrogen added to 2 atoms of oxygen gives us
64 gram per mole. So that's how we call our molar mass. So we just add it over here, 64 gram per mole. So I'm just going to wipe this off. So when we punch this, mole is equal to 9.6 divided by 64. We'll be having mole equals to 0.15. 0.15. Now remember, the question is asking us to look for the volume of nitrogen, not the volume of ammonium diisonitrate 3. So this is 0.125. So we'll write it in it here so we can get the mole. This stoichiometry, you should remember, is based on simple comparison between different compounds in a balanced equation. So this will be 0.15 over there. So what we are going to be doing is simple comparison. If 1 mole of ammonium diisonitrate 3 gives us 0.15 mole after calculating the molar mass, with the mass and the molar mass, how many moles, okay, let's put an arrow here, how many moles will nitrogen gas gives us? It will be the same thing, because 1 times 1, if we cross multiply, it will be 1 times 1 divided by 1, which is still 0.15. This figure would have changed if we were comparing with hydrogen that have different mole, which is 2 over here, that have different mole. But since nitrogen and ammonium diisonitrate 3 have the same mole in the balanced equation, which is 1 to 1, it will have the same mole, same thing when we calculate the mass over molar mass. Hope you understand. So I'm just going to wipe this off. So since we have found our mole of nitrogen gas, we are not asked to find the mole. If not, we would stop here. We are asked to find the volume. And remember what I said in earlier times of this video. I said mole is equals to volume over 22.4 dm³ for STP. So the question told us STP, right? Yes, the question over here told us STP over here. So anywhere you see STP and you're asked to look for volume, your mind should be going to this formula, which is mole is equal to volume over 22.4 dm³. So volume will now be equals to our mole times 22.4, and our mole over here is 0.15 times 22.4, and this will be equal to 3.36 dm³. So that's the final answer. So what am I going to do? I'm just going to recap on how we got our answer. First of all, we have to write the balanced equation. That's the first thing to do. Then you write the comparison of the mole, which is over here. We wrote comparison 1 to 1 because our question was only referring to nitrogen gas and ammonium diisonitrate 3. So that's the only thing we'll be using to compare the question. So then afterwards, we looked for the mole using 9.6 gram. In the question, we looked for the molar mass. Then we found this mole, which is 0.15, using mass over molar mass. So 9.6 divided by 64, we got 0.15. Then we have to put that same value under this our 1 mole and compare with the other 1 mole of nitrogen, since we were asked to look for the volume of nitrogen and not ammonium diisonitrate 3. So since we got the volume of ammonium diisonitrate 3 and it's comparing the same mole, which is 1 mole to 1 mole, we will still have the same value of mole for nitrogen gas. So hence we found the mole of nitrogen gas. We went back to our question and we found out that we were asked to look for the volume at STP. And when you are looking for volume at STP, the only formula that comes to your mind is this, which is mole is equals to volume over 22.4 dm³ at STP. So then we looked for the volume using mole times 22.4 dm³. So 0.15 times 22.4 give us 3.36 TNQ. Hope you understand. If you have any questions, please leave it on the comment section. I'll do it to reply you very fast. So for our test 3, we have a question which is asking us to find how many grams of HCl that will be required to react with 5 grams of sodium hydroxide. So this is our balanced equation for the reaction. Now we'll pick out our two reagents that we are using for this reaction, which is the question is requesting for HCl and sodium hydroxide. So that's the two things that we're going to use. And comparing their mole, we'll be having 1 mole to 1 mole. So we are going to be looking for the mole of sodium hydroxide since its mass was given to us in the question. So it will be mole equals to mass over molar mass. Mass over molar mass. So the mole is equals to, we're having mass, our mass is 5 grams. Up over here we have the molar mass to be 40 grams per mole. You can see how I found the molar mass using their individual masses. So 5 grams over 40 grams per mole will give us the mole of sodium hydroxide as 0.125. So that's our mole of sodium hydroxide. So we'll come over here with 0.125. So we're asked to look for the mass of HCl. So comparing this, if 1 mole will give 125 mole of NaCl, will give us what? Will give us X. So it will be X equals to 1 times 0.125, which is equals to 0.125. So since it's the same mole from the equation, since we have the same mole from the balanced equation, we'll be having the same mole even after we solve using mass over molar. So since we already have the mole of HCl, which is 0.125 mole of HCl from equation comparison, so we are going to be looking for the mass, since the question is asking us to find the mass of HCl. So for us to find mass, and we have mole, we need molar mass. So our molar mass will be molar mass of HCl. So molar mass of HCl will be 1 plus 35.5, which is 36.5. Hence, the mass of HCl will be mole of HCl times molar mass of HCl. M means molar mass. Then the mass becomes 0.125 times 36.5, and if you punch that, it will give us 4.56, which approximately this will give us 4.6 grams. And definitely our answer is option A.
Alright guys, so for our question 4, we have a question which says 25 cm cube of the solution containing 1.33 grams of Na2CO3 in a 25 cm cube requires 24.5 cm cube of a solution of H2SO4 for complete neutralization. What is the concentration of the acid? This is a question that involves neutralization, and in turn, since it is reacting with a triazocarbonate, CO2 gas will be liberated. So first of all, as we like to do, we write the balanced equation for this reaction. So this is the base Na2CO3 reacting with H2SO4 to give us Na2SO4 plus H2O plus CO2. So this is the balanced equation for our reaction. This is a basic salt reacting with an acid to give us another salt, water, and liberating CO2 at the end. So if you examine the reaction very well, it is well balanced. So remember our formulas we did at the earlier times of this video, where I told you that mole is equals to concentration times volume in dm³. So these are major focus for this question. This is the formula that we'll be using to solve this question in S-stream. So since it involves two compounds, an acid and a base, and we are being asked for the concentration of the base, it is very right to say the mole of the acid equals the mole of the base. So this is the mole of acid equals the mole of base. So we can say that this is volume of acid times concentration of acid is equals to volume of base times concentration of base. So I'm just writing this down so you know how we get our formula for solving. This is for base and this is for acid. So if you understand how we got this, you like to wipe it off, you can keep this in your mind so that when we get all our parameters for solving, we can apply it to our solving. So now we are going to be writing our parameters out over here. So the concentration of our acid is what we are looking for, which is H2SO4. Concentration of H2SO4 is what we are looking for. We don't have that yet. So, but the volume of the acid, we have the volume of the acid to be 24.5, in which when we divide by 100, because we are working with cm³, when we divide by 1000 rather, it will give us 0.0245 dm³. So these are volume of our acid in dm³. Volume of our base, is 25 cm³, but when we convert to dm³ by dividing with 1000 to give us 0.025 dm³. Now our concentration of our base, we don't know that yet, so we have to find that with the parameters that was given to us. Remember our base, which is our basic salt which we are using here, which is this. The basic salt we are using, Na2CO3, contains mass 1.33 grams, and it has its molar mass. Molar mass, we know how to find that, which is we're looking for 2Na plus C plus 3O. Now 2Na will be 2 times 23 plus 12 plus 3 times 16, and this will be 46 plus 12 plus 48, which will give us 106 gram per mole. So that would be our molar mass, 106 gram per mole. So without taking much time, we'll just write our 106 gram per mole here. We were given an extra volume of our base, Na2CO3. So the volume that was given to us is 250 cm³, and when we divide it by 1000, it will be 0.25 dm³. Now the formula we are going to be using to solve this is two mole formulas. So we are going to be relating two mole formulas there, and this will be, remember, mole equals to mass over molar mass, right? So now has been established already, and mole equals to volume times concentration. So in the same way, we can say that mole is equals to Mole is equals to mass over molar mass. Mass over molar mass is equals to volume times concentration. This is the formula we're using to look for the concentration of the base. So concentration of base would then be equals to mass divided by molar mass times volume. So when we input our figures in, we'll be having 1.33 grams. Sorry, it's a little jam-packed. 1.33 grams divided by 106 gram per mole times 0.25. And when you punch that in your calculator, you'll be having 0.05 mole per dm cube. 0.05 mole per dm cube. So we'll just come over here and write the concentration of the base as 0.05 mole per dm cube. Now with this, we can use these parameters here to solve for the concentration of the base. Hope you understand how I got the concentration of the acid by relating two mole formula that we established earlier, which is mass over molar mass equals to volume times concentration. I'm just going to wipe this off so we can go over to the business of the question. So the question is asking us rather to solve for the concentration of the acid. So the formula we established earlier, which is concentration times volume of base, is equals to concentration times volume of acid, where concentration of acid becomes concentration of base times volume of base, is all for base, divided by our volume of acid. Hope you understand. I just got this from our first formula we have here. So when we make concentration of acid, which we are looking for the subject of the formula, we'll be having that over there. So conc of acid will become conc of base, which we just look for, is 0.05 times volume of base. Now volume of base there is 0.025 divided by, remember this is conc of acid, 0.025 divided by the volume of our base, which is volume of our acid rather, which is 0.0245. And when we multiply and divide that in our calculator, we will be having 0.05 mole per dm cube. So this is our final answer, and this is option C. So option C is the right answer. So alright guys, we'll stop here for now. This will be part 1 of the video. For next time, please click the notification button so you'll be notified when I post the stoichiometry of limiting reagent, which is very important, and I'm going to be breaking it down. Thanks for watching. Please subscribe. God bless you.